talk about the beginning of the universe. Was there a beginning to the universe? Well, a lot of people seem to think of it that way, and they've, it's been around for hundreds of years, thousands of years. People have always believed that there was a moment of creation. A little different in the old days. They thought it was some kind of God, some supernatural being that moved the magic wand, right? And made the world somehow. And today we have the same situation, but without the magic wand, without the being. It just did so by itself. And a lot of people believe in that as well. In fact, I would say that if we carried out a poll throughout the world, 8 billion people, we'd probably find out that most people, absolutely most people, just about everybody believes that there was a moment of creation, that the universe got started somewhere. You know, it wasn't always there. And meaning it's not eternal in both directions of time, that there was a moment of birth and maybe there is a moment of death, right? Well, under the rope model, that dies a sudden death, okay? We have a totally different view here of what the universe is and why it cannot have come into being, matter come into being, right? Or space for that matter, that's even worse. Okay, so let's start first with what we propose, then we'll move on to what other people propose out there, okay? So here's our proposal. This is what we think is out there. We're saying that there's a single thread that weaves all matter in the universe, every atom. So we're all connected, and if we were to untangle, every atom, every rope that interconnects them, right, we would end up with this, a single closed loop thread. That's all there is, okay? And a single thread is what comprises matter. And there you can see more or less what we're proposing. We're saying that there's this thread out there, and if you were to follow from one end to the other, all around, you would go through the entire, through every piece of matter in the universe. In other words, all the matter that you see there, all the stars, all the galaxies, every single atom in the universe, every bit of matter belongs to this thread, is part of this thread, okay? So if you started at one end, you would end up where you started if you just followed all along through every atom in the universe, through every single rope that interconnects any two atoms in the universe. Okay, that's our proposal. Okay, and so question that people say, well, how did the thread come into existence? When did it start? That's what people want to know. How did it start? When did it start? Did it start? And it had no beginning. And the main reason there is that you cannot even imagine a mechanism, okay, where you have nothing, absolutely nothing, whatever nothing is to you. We say that nothing is that which has no shape. And we cannot conceive of that which has no shape suddenly acquiring shape. Nothing to something. Or vice versa for that matter. You cannot conceive of something losing length, width, and height, losing its structure, its architecture, and converting into absolutely nothing, that which has no shape. I mean, we can imagine this maybe in a movie, and we just do it. Turn something into nothing. We can do that in a cartoon or whatever. But the question is, can we do that in real life? Can we imagine that even in physics? And the answer is absolutely not. You would have to come up with a mechanism. By what mechanism does nothing become something, or vice versa? And since there is no mechanism, all those people who believe that there was an origin to the universe do not have a reason for believing that. Okay? Because the only way you can maintain that assumption, right, is by showing us the mechanism. You got to have a theory of the mechanism of how something became nothing or nothing became something. That's the issue. Okay, so what do we propose? Well, very simple. Here we're saying that every atom in the universe is physically connected to all other atoms. That's how simple our proposal is. Really, it's a very simple universe. What we have is all atoms, specifically the hydrogen atom, connected to all other hydrogen atoms in the universe. And if the atom is bigger, like a uranium atom that has essentially 92 hydrogen atoms crushed and blended into this big atom, which we call the uranium, well, we have to look at the components, at the individual hydrogen atoms. And part of the problem there is that you have neutrons, right? And there are usually, in isotopes, more neutrons than protons, okay? And so we have to account for those as well. And we're saying that the neutrons essentially are hydrogen atoms that do not have charge. And that's what we would have to explain. Why doesn't the neutron have charge? And that is part of the discussion that we have today, right? That in our lecture today. Okay, so this is what we propose for the entire universe. It looks more or less like this. All these tiny little atoms, you can look at that and say, well, they're atoms. You can also look at them and say they're galaxies. You maybe look at the universe. Maybe you're looking at a little piece of bread, and those are the atoms in it. You can look at it any way you want, and you can see there are little lines connecting all of them, and that's essentially how simple our universe is. Just atoms that are all interconnected. That's our universe. So you ever wanted to know what our universe looks like? Is it impossible to conceptualize? No, it's very simple. It's absolutely very simple. You have two atoms bound by a rope, right? Electromagnetic rope, that's the elongated mediator that interconnects any two atoms, and just multiply that by a very mathematical number called gazillion. And that's our universe. Just gazillions of atoms bound to each other. That's it. That's how universe is. That's the matter in the universe. What serves as the backdrop is space. Space is nothing, synonym of nothing, of vacuum, which is that which has no shape. Atoms and ropes have shape. Space, vacuum, nothing, nothingness, has no shape. That's it. That's how simple our universe is. Okay? And that's what the word universe means. Atoms and matter, matter and empty space behind it. Okay, we could have under the rope model multiverses. This is just something for you to ponder, to think about. We don't propose it, but it could happen, right? So we don't say that it cannot happen. It's a possibility, but it's just for talk at the water cooler. Nothing more than that. And it could look like this, where you have different threads forming different bits of matter, but none of the atoms of one universe are connected to any of the atoms of another universe. So we could have these parallel universes or multiverses, and we all share the same space, so that black stuff is the same thing that everyone uses. The only difference here is that all the matter in one of these, we'll call them islands, right? All the matter is connected between them. They're all interconnected. All the atoms in one of those ovals there are interconnected, but none of them are connected to one of those other islands or universes, okay? There's still a single universe because we have only a single space, for that matter, right? There's nothing that can separate us from another universe because we all share the same space. The only difference is that the atoms in one universe are not connected to those of another universe, okay? So this is our version of the multiverse. We don't propose it. We don't have to use it to explain anything. We're just saying that there is a possibility, and that's just food for thought for talk at the water cooler, and that's nothing more than that. Okay, so what are we proposing? Well, we propose the electromagnetic rope, which looks more or less like this. We're replacing the electromagnetic wave, which is not a physical object, with the electromagnetic rope, a physical object. Whereas the one on the top is made of vectors and fields, which are mathematical concepts, just a bunch of numbers. The one on the bottom is made of 2 threads. I have to color code them only just so that you know that for the rope version, one is different than the other because one goes, around the other. But it's all the same thread. If we were to unwind every bit of matter in the universe, every rope, we would end up with a single thread. So the color coding is just to identify. That's nothing more than that. Arbitrarily, and to keep with convention, we call one the electric thread and the other one the magnetic thread. Only because of convention, we think it's easier than to try to create new words, which would be irrelevant. Just call it electromagnetic rope, electric thread, magnetic thread. That's it. How's the atom constructed? Very simple. We have the electric and magnetic thread. They come upon what we call an atom, a hydrogen atom. We have the electric thread, arbitrarily again. We could call that the magnetic thread. It wouldn't matter anyway. It's just one of the threads goes through the atom and out the other end. Okay? Whereas in this case, magnetic thread, in this example, that one coils around and builds the electron shell that encapsulates the electric thread. Gazillions of electric threads from every rope that's converging upon our atom, from every atom in the universe, builds the proton star, and the magnetic thread from gazillions of, again, ropes converging on our atom, coil around and they build this membrane, this ball of yarn that encapsulates the proton star. That's our model, and hopefully you get the idea, okay, of how our atom is constructed, okay? And one thing we need to do is show what is the difference between an atom and a neutron. They have approximately the same mass, but they say, well, the atom has charge, whereas the neutron does not. You have the electron that has charge, the proton has charge, or so they say. And they say these are charges, whatever that means, right? Just a number as far as math is concerned. And how is it that there's a little difference between an atom and a neutron? And one of those is that the neutron is neutral, does not have charge, okay? And so we need to explain that. And this is our explanation for that. This is we have all the crisscrossing of ropes somewhere in the universe. You have to think about all the atoms that are connected to other atoms. The ropes in many places around the universe meet somewhere, okay? Wherever they meet, right, going from one atom to another, wherever all these ropes meet, we call that a neutron. The neutron would be the region occupied by a hydrogen atom. In other words, the volume. Okay, so that would be our neutron. Okay, so we predict, as they call it in mathematics, that under the rope model you should have not only atoms connected to atoms, but places where all these ropes intersect, and we're going to call that a neutron, especially the volume that an atom would occupy for that region. Okay. Okay, so that's our neutron, and so here we have them side by side. We have the atom, primarily the proton, right? You have the proton is just a convergence of threads where they crisscross, they meet, right? And the neutron has only ropes converging and intersecting. Okay, so that would be the different structure between an atom and a neutron, a proton and a neutron, right? You can see the difference there. One is just made of threads, the proton. The other one is made of ropes. Okay, and how does one convert into the other? Well, once you get that picture in your mind, you're going to see it right in a second here. But just picture what I'm showing you there. So try to keep that in your mind for a second. Okay, and here we go with the way they convert from one to another. We call it beta decay. That's what it's known as. And here it is. Here you have the proton star. And what's going to happen is the thread is going to unwind from the center, okay, and convert into an atom, okay. And then at the same time, about 15 minutes later, because that's how long a neutron, a free neutron, lasts as a free neutron in space, then it converts to an atom, and an atom converts to a neutron. And again, that's called beta decay, positive and negative. And what we're saying is all we're having is a rope that is unwinding from the center outwards and creating the atom. And then when it rewinds backwards, right, for whatever reason, and then it builds the neutron again, okay? And that's why it has no charge, because what does the electron do? Well, it pumps, it expands and contracts like you see there, and that's the famous charge. There's no negative or positive in the rope model. All we have is an expansion and contraction of the electron shell, electron membrane, and what it does by doing so, it torques the ropes. So when it expands and contracts, it's torquing the ropes, and that's light going along the ropes to another atom. And there you have it. Those are the changes from what is known as beta decay, and that's from atom to neutron and neutron to atom. And you have both versions, back and forth. No positive, no negative, none of that stuff. Okay, positive and negative have no place in physics. It's just a mathematical concept. They don't know what it means. They don't know what north and south means. Those are just labels. They could have said X and Y. They have no idea how positive physically is different than negative. Okay, so what's the issue? The issue is that all atoms in the universe can occupy a single location, and they cannot occupy two locations. Okay, so they can only be at a single location. And we call that, in order to understand this concept, which is sometimes very hard for some people to understand, is that we invoke the tool which I've created, known as the universal movie. What is the universal movie? Well, it looks something like that. You have the static concepts that you see on the top, such as object, distance, location, existence. Those are just examples. There are many more. And at the bottom, you have the dynamic concepts, and you can see that those take up at least 2 frames of the universal movie. You need 2 or 3 or 4 more frames of the universal movie, locations of objects, in order to conceptualize the dynamic concepts that you see at the bottom. Whereas the ones on the top, you can conceptualize them in a single frame of the universal movie. Just every atom at a given location, meaning distance from each other. Those are all static concepts. So is the concept known as existence, to exist. Exist requires no motion whatsoever. You can conceptualize existence in a single frame, because the definition of the word exist is object that has location. Both object and location are static concepts. All the ones at the bottom, they all require motion. And for motion, you need 2 frames of the universal movie, meaning you need 2 locations of an object as a minimum. Okay, so let's invoke God. He's got his camera. Give me a second here. I'm going to get rid of this and this one here. Okay, so we have good old God, and we're going to invoke him, and he's going to take a snapshot for us of the universe so that we can find every atom in the universe at a given location. Single snapshot, no movie, just picture. Like if you took a snapshot at home, you know, every atom that's in there is static in your picture, in your snapshot. Okay, here it is. Okay, God takes a snapshot, a 3D snapshot, right, of the universe, and there you would have every atom in the universe. Okay, and you can see there are no dynamic concepts there. There's only static concepts in that picture that God took for us. Okay, he was nice enough to do that for us. And so this is what it would look like. Okay, Father Universe only recognizes what he sees there. In other words, there is no movie as far as Father Universe is concerned, because Father Universe only includes every atom at a given location. There's a distance between every atom in the universe, occupies a single frame. More important here for you to understand is there is no past and no future. Okay, every atom has location only. You cannot go to yesterday and find those same atoms, because Father Universe does not keep a running log of every atom where it was in the past. He's got no file cabinet. Okay, so when he's at frame 633, he's not at frame 632 anymore, and vice versa. And when he's at 633, he's not at frame 634. He's still not there. All the atoms have not moved to the new location. Okay, so when you look at Father Universe, he only consists of every atom at a distance from all others. They only have location. All of these are static concepts. Okay, and so this is really more or less what you should be thinking about, something like that. If God took a snapshot, it's a single frame. Okay, let me get rid of this. We'll take a single frame, and you have every atom in the universe. Okay, and only static concepts. We have to distinguish static concepts from dynamic concepts. Okay, what's the problem with this for the establishment? Well, the establishment, and that is for many years now, over 100 years now, says that you can travel to the past and you can travel to the future. They say for sure you can travel to the future. A lot of them question whether you can travel to the past, and there's a debate about that as well. Okay. Why? Because they say, well, we're going to have a problem with causality. You go back, kill your grandfather, so you were not born, and things of that nature. No, you cannot travel to the past. You cannot travel to the future. Why? Well, because there is no frame to land on. And in order to conceptualize this really good so that you really get a handle on what I'm saying here, right, is that let's say you have an atom, and it's in your chest somewhere, right here, okay? That atom must have belonged to something else in the past. I mean, you eat, right? You poop, you sleep, you do all these things every day, and your body is changing. Different atoms are forming part of your body as you go along through life. Okay? The atoms that you have today probably were not the same atoms you were born with. Maybe some of them are still there, but you're changing all your atoms constantly. They say like you change most of your atoms like every 3 or 4 months. This is what they say out there. But for sure, whatever atoms you have now, millions of years ago belonged to something else. Okay? So let's say you have an atom that's here in your chest. Okay? We'll call it a hydrogen atom. Okay? Just to make it simple. And this atom, this hydrogen atom, 65, 70 million years ago belonged to a dinosaur. Okay? So it was maybe in the chest of a dinosaur. Okay? Now let's say we invent this time machine. The time tunnel, right? The wormhole, whatever you want to travel through, no problem. You travel, you go back to the past, and you get to see this dinosaur, the one to which that atom belonged to 65 million years ago. Okay, and here's an image of that. You took the time tunnel, whatever, okay, wormhole, and you get to shake hands with the dinosaur that had the same atom that you have now in your chest. But that atom, at that moment in time, when you got there, is also in the dinosaur's chest. So that atom, right now, at that point, when you went to the past, is at two places at once, because it's the same atom, okay? So you have it here today in the present. You go to the past, you didn't lose that atom, it's still there. You arrive, through the time tunnel, a couple seconds, you're there, 65 million years ago. You shake hands with the dinosaur who has the same atom in its chest, right? And so the atom is at two places at once. And that is a little irrational. And I think that shows that, no, you cannot travel to the past. Can you travel to the future? Well, if the dinosaur came through that same tunnel to meet you here, he's traveling to the future, right? He's traveling to our days. He's got his atom there, and you have that same atom here. Well, you can't. I mean, unless you're Siamese twins and share an atom, we got a problem, don't we? We have two things, two animals, two living entities that have the same atom, in their own chests. Please explain that, okay? Yeah, and so that's why it's irrational to talk about travel through time. It destroys the nonsense invented by the mathematicians, which is just a mathematical calculation. It's got nothing to do with physics. It violates physics, their calculation. It just shows that all their nonsense equations where they talk about time travel, time dilation, all this nonsense, has nothing to do with the reality. The explanations that they give for time dilation are irrational. It doesn't mean that there's something wrong, out there that you measure time differently. That's something different. But to conclude from there or extrapolate from there that you can travel to the past or to the future, that's poppycock.